All right, so today we're going to kick off the phase 4 project, which is crazy. It's the last project right before capstone. I won't go into too much about like picking the project because you have already picked your project, but it is worthwhile reading through some of this. I mean, I think something that I did tell you all to consider is, what you intend on doing with your capstone, whether, your capstone contrasts your phase 4 project or if your capstone builds on your phase 4 project. I will say after this project is done, we'll be doing the presentations for the first 2 days, not next week, but the week after. So you'll see on the calendar, we'll have half of the presentations on Monday, half on Tuesday. And then I will give you all like the capstone requirements and my like capstone guidelines on Tuesday. So I would say after this project, please take a good break. Don't start working on your capstone just yet because burnout really does happen. So I really recommend that. So I'll just be walking through my versions of these projects, I guess. Definitely you can take the project whichever way you want, but I'll walk through some of like the things that I want you to include in your project and the things that I'll be looking out for. And because there are 4 different projects, I'll be going through each one. And yeah, for each project, the things I'm looking out for are going to be a little bit different. So yeah, again, the deliverables are going to be exactly the same, same as last time. You will also notice maybe I've tried to configure it such that only one person per group needs to make a submission. I've tried making the groups in Canvas and let me know if it doesn't show up for you that way. I believe that if you go to, and let me just do this for you all. When you're submitting the assignment, you may or may not see this. So if something is weird or not working, please let me know. Again, if you submit your project a little late, it doesn't really matter to me either. So if you have issues with this submission, let me know as soon as possible. This is something that's like a new feature that I'm trying to use so that I don't have to like copy and paste the feedback for everybody. So yeah, and like also all of the grades will be shared. Well, not the grades, but the rubric and the feedback will be shared across every team member. So just keep that in mind. But the things that you're submitting are going to be exactly the same, just that this way, each person in the group doesn't need to submit it on their own. I think one person should be able to submit it and it should be fine, but I'm not too sure. That is, yeah, this will not affect your project grade or anything. All right. So I've linked the guideline for this in the guideline, I guess. And this is, again, setting up your repo. I know this time we do have a few groups of 3. So, just add your group members as collaborators. I will say if you don't want to deal with, the git push or like merge conflicts and stuff like that, feel free to send each other stuff. I really don't mind. I just think it is important to have, your work on GitHub. So yeah, I was talking about here, it should be that only one person needs to submit. Also, the people who don't have partners, I don't know if this will affect your submission. So if anyone runs into issues with that, just let me know. So yeah, another thing that might apply to everybody, if your data file is too big, GitHub does have a limit of how much information you can store per repo. So if you have a very large data file, add the file name or the folder name into your git ignore. And this can be done, on the GitHub interface, or you can also edit your git ignore through any of your text editors. Because the git ignore is a hidden file, it starts with a period. It might not appear when you do ls, but if you've cloned down your repo and there is a git ignore in your repo, it is there. So if you have any issues with like your git ignore, let me know. If you accidentally try and push a large file onto your GitHub and now you have like issues with committing and pushing, also let me know. I do have a few lines of code that that I have to fix those issues. Something that also applies to everybody, you still have to come up with your business case. More recently, a lot of the one-on-one questions have been about, what should I prepare for in an interview? What are companies looking for? And they're really looking for how you can contribute to their team as a data scientist. And every company has a business case. So being able to connect the data science tools that we're using to some decision making or some, I don't know, actionable insights that a company could use is very, very important. So for any of your projects, just come up with a business case. I honestly don't care what it is. What's important is that your recommendations at the end link back to your business case. With the last project, I did see a little bit more of that, but this project, I'm really, really going to make sure that that is a part of what you guys are doing. Any questions before we dive into like the individual project guidelines? All right, well, I'm gonna do this, and this is in order of, I don't know, the topics that have turned, the order of topics in phase 4. So to start, we're gonna do recommendation systems. So there's a couple groups doing recommendation systems. So to start, again, set up your business case, have an introduction. And again, this applies to all of your projects. The more documentation that you have in your Jupyter notebook, the better. So do write out as much information, give as much contextual background as you think is necessary. I would say the more, the better. So for EDA, for recommendation systems, your EDA, you want it to be helpful for your modeling, or you can explore what you're curious about. The provided data set is the movie lens data set. That is actually a pretty common data set with a bunch of like user ratings for different movies. It also comes with a CSV with the actual details of the movie. I believe like the ratings data is only like a movie ID, if I'm not wrong. So you might want to use the actual movie data in your CSV, like like what is the average rating for all of different movies? What genre tends to be like the highest rated, stuff like that. Something that we did talk about with collaborative filtering models is that there is popularity bias. So maybe you just want to like have a list of like the top rated movies just so you can confirm in your recommendations, is there a popularity bias that you want to look out for? I will say the recommendation systems project is going to be pretty straightforward. I'm really only expecting you all to use the surprise library in your modeling. The surprise library does have a few models. There is the KNN baseline model. If for those of you who went through the labs, they did use that as a baseline. So by all means, use that as well. Something I want to mention here, you do need a baseline model. So choose a baseline model. Use a surprise library. There is not only SVD, but there are like, I think there's a couple like modified SVD models. So feel free to just pick a couple of them, tune the hyperparameters. You can use grid search with surprise. And then once you're done with that, if you feel like you have more time, this is really not necessary for this project. Because there is the movie CSV, the movie's CSV with the features of the movies, you can try out LightFM. It does take a little bit to figure out because a lot of the LightFM objects work in the same way as in Surprise, where you have, the reader object and the dataset object, where you can't actually inspect your data in like with the data frame. So I'm really not expecting you all to do this, but if you want to, that is there. In terms of business recommendations, perhaps through some post-modeling EDA, you can see like because a collaborative filtering model essentially fills out the entire matrix, you can aggregate that to see what is the average rating for each movie, or what is the average rating across the entire matrix, or stuff like that. You can do a bunch of post-modeling EDA. Are there subsets of movies that are getting higher predicted ratings? In terms of your recommendations, they can actually be similar recommendations to that of your phase 1 project, right? Remember we did that Microsoft Movies project? Maybe based on the movies that are consistently getting higher ratings, you can make recommendations to like a movie studio to create movies like whatever the highest rated movies are. As your final product / future work, are you able to generate ratings for a new user? I know there is already some code built out. If you have gone through the lessons, feel free to repurpose that. And also something that if you're very, very interested in recommendation systems, there is like a set number of models that you can use to make recommendation systems. How can you make them more robust? You really can get very creative with what you use to represent users and what you use to represent items to get more robust recommendations. Maybe think about what other models you can incorporate. Maybe some of like the nearest neighbors models that we used in phase 3. So as future work, maybe just brainstorm together with your group members what are some ideas to make your recommendation system more robust. Any questions on recommendation systems before we move on?
I have a quick question. I know you specified that when you're running the recommendation system in Surprise, you need the format user ID, item ID, then rating.
Mm-hmm.
Will the Surprise library still work if you like generate new features into that and they're like either at the beginning or the end, or is it strictly you need to have those 3 columns and any other data could potentially hurt your model?
Yeah, so for Surprise, you strictly are only using those 3 features. Whether you reweight your ratings based on something else, it has to take in those 3 columns. So like one, I guess an easy way to expand on that is, let's say, you have that movies data in like the movie features. Maybe you reweight the predicted ratings after you run your model. That's something that you could do. Or you add like levels of filtering after you have your predicted rating. So let's say you know that you want to recommend like a specific genre of movie. You can get all your predicted ratings and then filter it based on genre, stuff like that. I will say that like if you want to incorporate the movie features in with the collaborative filtering model, you would have to use LightFM, because Surprise, at least not to my knowledge, I don't think Surprise has an easy way of incorporating item features. But yeah.
All right,
Got it. Thank you.
Could you explain the idea of incorporating item features?
Mm-hmm. Do you mean like in LightFM or just like?
Yeah, like in LightFM, like, I mean, I don't really understand, like that'll just improve your recommendations. I don't know. I don't really understand the concept.
Yep. So the way that LightFM incorporates movie features is it is actually doing SVD, but then it's also changing your predicted ratings based on the similarity of the movies based on the movie features. So it's just reweighting. Yeah, it's literally just reweighting your ratings based on the similarity of the movies. So for example, in your collaborative filtering model, because it's not taking into context what the movie is really only filling out based on the ratings of that other users have given it.
Right.
It just does some readjustments based on, it doesn't make sense that, like for example, like if you have 2 very, very similar movies, but the predicted ratings are like 5 and 1, it will do some little adjustments to keep that out.
Gotcha. Okay. Cool. So for the features that you would include is it just that you would include certain features of the movie, or can you include like multiple features or?
Yeah, so the way that LightFM does it, you actually feed it in a data frame. I believe you have to make sure that the movie IDs match the ones in your collaborative filtering data and your movie data. You just have to make sure that there's a movie ID that they can use to match them up. And you can give as many features as you like. It can be like genre, maybe like, again, it has to be numerical. So you might have to do some work on like creating dummy variables. I don't have this here, but let me write that down to like add some links. There are some really good walkthroughs of LightFM that I used when I was using LightFM.
Yeah, that'd be great.
Any other recommendation system questions? All right, well, let's move on to time series. So for this project, the time series, the way that they set up this project is kind of interesting, I think. They basically provide you with a bunch of, basically, I think monthly data on like, I think the average price of homes sold in like, I think over 200 different zip codes. And your task is to pick what are the 5 best zip codes to invest in. So first, with the EDA, and I think something that's important to discuss with your group members, or if you're working by yourself, something that's important to think about is what is going to be your approach with modeling. Because with, I think like 250 zip codes, is it the most efficient thing to create like 250 different time series models? Probably not. I will say that for this project, I'm just looking at, if you just do one traditional time series model, That's all I'm looking for. Whether you create one time series model to be generalized to all the zip codes, that's something that you can do. So do a bunch of EDA. Again, with like over 200 zip codes, how can you do this efficiently such that you're not, doing the same EDA for 250 different zip codes? One approach that I've seen a bunch of students take is group your zip codes, maybe through like clustering, or maybe just like by plotting overall trends. Maybe you can end up grouping like, all right, these zip codes have upward trends, these have like flat, these go down. I don't remember what the patterns are, but maybe you can do some clustering and group the zip codes in a couple different groups. And then you maybe have like a model per group. Things that you're definitely going to want to check for, whether you do this for a single zip code or a group of them. Check for stationarity and seasonality. Even if you don't use them in your model, these are things that are very, very standard to have in a time series project. This, again, as a level up, after you've done your modeling, this should not be like something that you do with your first model. You might incorporate exogenous data. The data does come from Zillow and is based on zip codes. So you can very easily incorporate other like demographic information about different zip codes, for example, but this is definitely not what I'm looking for in this project. Feel free to incorporate it if you feel like you have time, but I'm not expecting any of y'all to incorporate that. So with the modeling, as a first step, think about how you're going to do your train test split. It could be dependent on how many data points you have. You can also get more recent data to act as your, your test set. So definitely consider those. With your modeling, you definitely want to start with the traditional time series models. Don't go straight into Facebook Profit or your neural networks. Do not start with that. If you're interested in time series and you're interested in doing forecasting in your job in the future, it's very important that you know how to work with these traditional time series models. So yeah, whether you create a single model for all the zip codes or you create multiple models, it's important to demonstrate your ability to work with these ARIMA-like models. As part of your modeling process, again, I think this is a really great tool, especially because how you define the number of differencing that you need and stuff like that, it's hard to be very sure of what the best number is. Perhaps you can use AutoArima to tune your model, but don't start with that. I meant to link it here, but I think I forgot. So I will make a quick note to link AutoArima. But any questions so far about this time series stuff? Cool. If you want to change the prompt that was provided, by all means, feel free to do that. You don't have to, maybe you can like cut down the number of zip codes that you have from like 200 to like maybe 5 to start. So if you want to change your question up, that's absolutely okay. All I'm looking for is that you know how to intuitively build out a traditional time series model. So just be aware of that. If you don't feel like dealing with this like 200 zip codes, you have flexibility there. So yeah. Because the prompt that was provided, there are a lot of ways to tackle this problem. So yeah, there are many ways to determine the top zip codes. It is very important that you document your thought processes and back up your modeling decisions. So with this time series project, I will expect to see reasons why you're deciding to group your zip codes, or reasons why you've decided to use just one model and run them for all. If you really want to level up, you can incorporate like AutoArima into a function to automatically determine the best like PDQ values for each zip code, turn that into a function such that you would have unique models per zip code. So yeah, it's really up to you how far you take this. But again, I do want to reiterate that all I'm looking for is that you are able to intuitively build some ARIMA model. To level up, it's good to just try implementing Facebook Profit. It's just known to have better forecasting ability than traditional models. So if you just want to have like some point of comparison, do that. Oh, something that I forgot to put here, you also need a baseline model. So whether you choose like an AR model or an MA model, like one of the simpler models as your baseline, or you want to do like your first go at an ARIMA as your baseline, feel free to do that as well. So pick a baseline model. Any questions as I type this out? Perhaps a straight line. Up to you to decide. All right, so with your business recommendations for this time series project, if you're following the prompt, obviously your recommendations are which zip codes to invest in. It's also very important, you know, if you are some sort of like investment advisor, it's important to address the caveats of your model. Like if you're using a linear model to make these predictions, there are obvious drawbacks to that. So it's very important that you document that and you are mentioning these in your presentation or in your notebook. Any questions before we move on to talk about the NLP project? All right. So with the NLP project, again, setup will be the same. So to start EDA, at the end of the day, if you're doing the project that is provided, it is a classification project. Something that I did wish that I emphasized more is that you make sure that your EDA is going to be comparative to aid in your modeling. So the project is to classify the sentiment of tweets talking about, I think, Google and Apple products. So it's important that your EDA reflects the differences between the two, differences or similarities between the two, between like positive sentiment, negative sentiment, and like neutral. So for example, word clouds, right? Maybe you have a word cloud for all the words that are used in all your tweets, but something that would be more helpful would be to have a word cloud per positive, neutral, and negative classes, just to see what are the different most salient words within each class, because those will likely end up being important words from your model. So yeah, word clouds are good for presentation, as I mentioned before. So I still want to see some quantitative equivalent of that. So literally like a bar graph with like the most important words, something that basically something that has numbers attached will be more informative. So you know the scale, because you know in a word cloud it's just the size of the word and it's relative. So yeah, I do want to see a more quantitative EDA on top of just word clouds. Of course, you can have the word clouds in your notebook as you're creating them, but yeah, I do want to see like more concrete quantitative EDA. To level up, you can try clustering as an EDA tactic, or I would actually recommend this more over regular like k-means or hierarchical clustering to use LEA. I will say LEA does take a little bit longer to run, but it has the very neat feature of being interactive. So it'll be more directly informative for you just to see what are the salient topics that are done. And again, I know the example of LDA that I showed was for the entire data set, but doing an LDA per the different classes will allow you to see what are the topics people are talking about when they have a positive sentiment versus what are the topics people are talking about if they have a negative sentiment. So again, remember that this should also be comparative. Any questions about NLP EDA? Cool. So for the bulk of this project, I see it going one of two ways. I do assume that most people are going to do this method just because this will be something that's very different from our last project. So we'll start with the second method. If you want to focus on modeling for this project, you can pick just a method of pre-processing, whether you use a count vectorizer, TF-IDF, word embeddings. Just do your pre-processing and just test a bunch of models. That will be a modeling heavy project. And then it'll be a very, very similar process as last time, just that your data is different. You can test like all the models that we had last time. Honestly, you can, because the process is so similar, if you are choosing to focus on the modeling, maybe you incorporate like a really simple neural network. But yeah, I would say most people would probably end up doing something like this, which is basically a project to explore different pre-processing methods. So this project style, you would basically try different pre-processing techniques. So again, whether you do just a count vectorizer, TF-IDF, maybe word embeddings. Again, word embeddings are not necessary for this project, because it is an appendix topic. So whether you do that, maybe you have different methods of feature selection. So an example of feature selection, maybe if you only, let's say you do like count vectorizer, which is the word count table. Maybe you only include words that have appeared more than like 100 times. I don't know in terms of scale what that means in that data set, but maybe you only include words that have appeared 100 times over all the tweets. That just makes sure that it will cut down the number of columns that you have. It'll make your model run a little bit faster. And in terms of TF-IDF, because TF-IDF appears as scores, maybe you can look at the average TF-IDF for every word across all the documents. And then maybe you have a TF-IDF cutoff. The TF-IDF values are usually pretty small. So maybe you pick like 0.001. So any word that has an average TF-IDF of much lower than that, you can just drop those features. Again, feature selection could be part of like the different pre-processing techniques that you explore. So as you're testing different kinds of pre-processing techniques, you don't have to do as much modeling. This just balances out the project a little bit better. 1 to 2 models, I think, will be sufficient if you decide to focus on different pre-processing techniques. I personally like to always include a tree model just for the easy to obtain feature importances, but also maybe include like a naive Bayes, just because those are very quick models and are demonstrated to work better with text data. So yeah, and then, post that, something that I did talk about, I think with most of you at your project reviews, post modeling EDA can also be very useful here. What are some of the words that, if you plot your feature importances, plot here, and it shows you what are the most important words. It's not always obvious which direction the word will go. So let's say the most important word ends up being like bug for like, I don't know, if you have like a buggy phone. Maybe most of the comments are saying that there are no bugs with this tech, for example. So you would want to do a bit of post-modeling EDA. If the word bug comes out as the most salient, see which class that appears more in. Any questions so far about these two like project processes? I do recommend doing this just because it will be a differentiator from your last project. But I mean, I wouldn't mind if you just did another classification project. If you feel like you do want to brush up on your classification project, you can do the modeling approach as well. But any questions at this point? All right, well, in terms of recommendations, again, business recommendations for this project, something that I'm going to really focus on. You should be drawing recommendations from your models. What words led to classifying your sentiment as positive or negative? And also, how can companies, as an example, how can companies potentially adapt with this model to better serve their customers? So if you found like through your model that a lot of the negative sentiment came from, I don't know, poor resolution as an example, maybe that's something that they adapt. Just as an example, it, again, will depend on how you set up your business case. Any overall NLP questions? All right, well, finally, we have our image classification project. Straight up, EDA for image classification is tough. Like, it's very hard to see, like, all right, what is the most, maybe you can find out like what's the most common color or pixel intensity, but I know that you all that are working on image classification projects, you're all working with X-ray data. So because of that, not very important. So EDA is harder for images, it always is. So do as much of a summary as possible in this section. Maybe talk about what your data set is like, where does the data come from, what is the class balance of your data, and also output a couple images from each class, just as an example. So as people are scrolling through your notebook, they see some examples of the images that you are using. So for the EDA, you're probably not going to spend a lot of time on it. So with modeling, as with the last project, you should start with a baseline model. What the baseline model is up to you. It could be like a very, very overly simplified neural network. honestly, if you take an image and like turn an image into a each image into a one-dimensional array, you could also throw it into a scikit model. You could potentially even use you could definitely also use the dummy classifier if you want. But yeah, it's up to you to decide what your baseline will be. It could also be the first convolutional neural network that you use. For this image classification project, you can experiment with different structures. I highly recommend including convolutional layers just because that is traditionally what is used for images. But technically, convolutional layers is part of the appendix. So if you just want to stick with dense layers, you can definitely do that. So it's convolutional layers are not required, but I really do recommend, because if you're classifying images, people are likely going to look out for whether you use a convolutional layer or not. Potential level ups, again, it depends on where you are in the project, like whether you have extra time. Feel free to implement pre-trained networks. Something else that you can do that I know is in one of the appendix labs, visualizing intermediate layers. That part is actually really interesting because you'll basically get to plot a heat map of where in the image the nodes are focusing on, or where are the nodes that, the nodes that have higher weights, where in the image they're focusing on. So yeah, you can also deal with potential class imbalances with data augmentation. That's something that you can do as well. Although all of these things are not required either. What I do want to see though is some tuning of your neural network, preferably using grid search or Talos, or manually change your parameters. I would like to see at least 4 different models. I wonder where that word went. Yeah, I'd like to see at least 4 different models with, it doesn't have to be drastically different. Maybe you're just like adding a layer and seeing how that changes. But with every change that you're adding to your model, I would like to see like a hypothesis of how it would affect your model. Maybe it's something as simple as increasing your accuracy, or maybe like the ability to increase recall on a minority class. But a quick documentation of why you're deciding to make this change to your model is going to be important. So let me just type this in. But at this point, any questions about this? Making changes to your model. Document why you're making this change and what your hypotheses are. I.e., will accuracy improve? All right, well, with neural networks, because it's very, very hard to do like a coefficient analysis or like any feature analysis of neural networks, the recommendations can be more qualitative or general. If you're seeing, very likely, if you're doing this project, there can be a lot more tuning that can be done to make your model perform better. But a big constraint might honestly be time, because each neural network might take like a couple hours to run. So for specifically the image classification project, you can potentially make recommendations on the model architecture. Like maybe say like what your possible like next steps would be. Like, would you add more layers? Would you include transfer learning? Stuff like that. For this project specifically, that will be acceptable. But yeah, those are the 4 projects that you all will be working on. Any questions at this point? All right. Again, I would like to reiterate that this project is meant to be a little bit more chill and straightforward as we ramp up to the capstone. I will say like most of these projects can be done in like maybe 3 days. And with the extra time, you can either keep building on this project if you'd like, or you can start thinking about your capstone. This is not a project that you have to go like above and beyond with. So yeah, my expectations for this project aren't like, yeah, I mean, a lot of these concepts you are already familiar with, so it shouldn't take too much time. What else did I want to mention? Yeah. Oh, I've been getting a lot of messages recently about like, what's the best use of time with this phase 4 material, and also like leading into the capstone. Just so you all know, the capstone is going to be 4 weeks long, plus the 2 weeks of review period. So you will be doing capstone presentations at the end of, or at the beginning of like the 5th week of your capstone. But usually people spend about like 2 out of the 4 weeks directly working on their capstone. A lot of that extra time is spent, revising material that you want to incorporate into your capstone. So that time is built in, just so you all know. So don't feel like you have to like play catch up before this project is done, before this phase 4 project is done. So just know that. I'll also be sending out a capstone like timeline, and basically this, but for the capstone. Of course, it'll be more general because the projects will be very, very different from each of you. But yeah, we're going to have a bunch of like intermediate checkpoints for the capstone, just to make sure that you are all on track to finish on time. But all right, any final questions? Cool. You can always Slack me if you come up with anything, so feel free to do that. Yeah, I don't think I have anything else to mention. Let me just quickly look over some of my notes. Yeah, if anyone has any questions at this point, feel free to chime in too. All right, well, I don't think I have anything else for you all. So good luck with this project. Again, if you have issues with submission, because I just tried adding that group thing on Canvas, let me know. It will not hurt your grade or anything. I mean, there are no grades in this class anyways, but it won't hurt your project pass probability if you're not able to submit it properly, because it technically will be my fault. So all right then. Let's see. Oh, let me see. Make sure there's nothing in the chat. Oh, deadline. The deadline is technically before presentations on Monday. That's a good question. Yeah, so technically the deadline is just before you present on Monday. Usually for blogs, I haven't really explicitly said this, but I really only check blogs at the end of the project due week. So I understand that blogs are hard for a lot of you. So yeah, if y'all want to take until next Friday for blogs, no, not next Friday, but the Friday after for blogs, feel free to take that time. Cool. All right then.